Continuing on with rational expressions, remember rational are like fractions. We're going to focus this time on addition and subtraction, but addition is where the concept on which we'll start. So remember that this really comes back from what we did with fractions. Back in fractions, when we talk about adding, we started with something like 2/3 plus 1/8. And we're like, okay, how do we do that? Well, we need to get a common denominator. And here, 3 and 8 are completely independent numbers. They have nothing to do with each other. They don't have common factors or anything. So we just times them together. Times by 8 here, and 8 there, and 3 there, 3 there. We've really times this by 8 over 8. That's the number 1, so 2/3. When it becomes 16/24 plus 3/24, we get 19/24. Once we have a common denominator, we can just add them. So a very similar thing will happen when we do rational expressions. Again, all they are fractions, but here we're going to say, what if we have something like 2 over x plus 3 over y? Notice these are kind of two unrelated numbers. So that's exactly what we're going to do, just what we did there. If we times it by y, times it by y, times it by x, times it by x, it's almost like we've cheated. We've just created the exact same denominator in both fractions. Well, that's what we did here, and so that's what we're going to do here. So let's do this. This is now 2y over xy plus 3x over xy, which equals together to give you 2y plus 3x over xy. So those are kind of nice when they look like that. A little bit different, but still in the same vein. What if we had something like a new problem, 2 over x plus 3 over x plus 7? Now don't get fooled. These x's, this x and this x plus 7, really kind of don't have anything to do with each other. This could be 2 and that could be, what's 2 plus 7? 9. 2 and 9. They're really not connected to each other. So we're going to cheat. We've got to get a common denominator just like we did with the 3 and the 8 by multiplying them together. All we do is say, oh, this guy needs an x plus 7 on top and bottom. And this guy needs an x on top and bottom. Well, look at what we just created. Here we have 2x plus 7 plus 3x all over this same common denominator, which is x times x plus 7. A word of caution right now. Based on what you've done before with simplifying, you may be tempted to take this x plus 7 and this x plus 7 and divide them out, cancel them. You may not do that, and this is the reason. That plus sign right there means that the top is not in factored form. We don't have it so that anything can cancel here. And so please be aware of that. Until you multiply everything out and simplify it and then refactor it, will you be able to tell if something can go. So let's multiply this out. 2x plus 14 plus 3x over x times x plus 7 ends up with, last thing equals, what is that, 2x and 3x is 5x plus 14 over x times x plus 7. And the bottom, if you want to leave it as a factored form, that's perfectly fine. If this top, we could pull something out and get an x plus 7, then we could cancel. But that's only when you can factor it. So watch out for that plus sign, and yeah, you can't cancel those x plus 7s. Okay. Now, that's how it works when these two just times together. Let's clear up the board a little bit and look at another fraction from before. How about something like 4/15 plus 7/65? Ooh, now that's an ugly one. If you had that in an arithmetic textbook, you'd be like, ew, yuck, what is going on there? Well, there's a secret thing that you actually probably don't remember very much about how to get common denominators, and some of you may remember this, but it's awesome. You can actually cut this number just into pieces by prime factorization, and you see what it's really made of. If you take the number 15 and you do the little factor tree, you get that it's 3 times 5. And over here, 65, there's a 5 that goes into that, and it's 5 times 13. Now, the reason that's so valuable is consider how we cheated kind of up here. See how we just put the 8 by the 3 and the 3 by the 8, and now they're the same? Well, look at this. Here we have a 3 and a 5, and there we have a 5 and a 13. What would we have to put over here to make it exactly like the other guy? Well, this guy has a 13, he doesn't have it, so put one on there. That's almost cheating. Well, sort of, yes. And what does this guy need? He needs a 3. Look at what we just created here. Those two are now exactly the same number. It's like your Dr. Frankenstein. You just created those things out of thin air, and now they are exactly the same. Well, it actually works. If you were to take 3 times 5 times 13, you get 195. And 195 is the common denominator of these two. You can see it's 5 times 13 is 65 times 3, and 15 times 13. It works. When you add these together then, you have it all over this 3 times 5 times 13, and you could multiply that out. But for our purposes, where we've got polynomials, I'm going to leave it like that. 4 times 13 is 52, plus 7 times 3 is 21. So that becomes 73 over 195. Why did I leave it like that? No special reason. You could write 195, but that's the process. So let's look at it with equations that are very similar to that in polynomials. So when we have something like 2 over x squared minus 25, and we add that to 3 over x squared plus 3x minus 10. Okay, let's make sure that everybody's aware we can't cancel those 3's because this 3 isn't a factor of the bottom. And we could multiply those two together and get this huge, big, complex common denominator like we did up here, but there's an even better way. Oh, look at that, factoring. We just spent a long time working on factors, so let's look and see what happens when we cut this guy up and see what he's really made of. That's x plus 5. X minus 5. Hey, that's pretty slick. And this guy is, let me see, x and x. And this is plus 5 and a minus 2. Now, if we look at it from that perspective, we only have to do one small little thing to make these two the same. This guy they both have an x plus 5. This guy has an x minus 5 that this doesn't have. So let's put him on here. X minus 5, just make sure you do it to top and bottom. X minus 5 over x minus 5, we've unsimplified to make it have a common denominator. And same thing over here, this guy needs an x minus 2. So let's put him in. Oh, look at that. Now, look at what we have created. This guy right here and this guy right over here are exactly the same thing. We just made a common denominator out of thin air. So let's write down what we have. We have 2 times x minus 2 plus 3 times x minus 5 all over this ugly mess down here. But at least it's the same. We can add common denominators we can add fractions when they have the common denominator. So there we go. So the top we do need to combine. Again, this x minus 5 and that x minus 2 can't cancel with anything on the bottom because they are not factors. They're not timesing to make the whole top. This plus sign in here messes up. So we get 2x minus 4 plus 3x minus 15 over that mess. X plus 5, x minus 5, and x minus 2. And then 2x plus 3x is 5x. What is that, minus 19? And then we would simplify. And so when I'm writing this out right now, think about, could we factor the top at all, pull out a greatest common factor, any type of factoring to make it simplify? And we can't. So we are now stuck. Oh, good. This is how you add fractions. And you just get a common denominator and add. combine the top and see if you can do any simplification. If not, then you're all done. Good.